I'd like to start by thanking the organisers for inviting me to speak at this meeting. For those of you who don't know me, I'm SCAIFE. I'm a Professor of Radio Astronomy at the University of Manchester in the UK, and I'm also the UK PI of the DARA Big Data project, which I will be talking about quite extensively today. More generally, I'm going to talk about how data-intensive science can drive human capital development for the fourth industrial revolution. And I'm going to do that through the lens of the Square Kilometre Array project and with reference to the DARA Big Data project. I'm sure that many people in the room will be familiar with the SKA project, but for those who are not, the SKA is a global astronomy project to build the world's largest radio observatory. It is comprised of 2 radio telescopes, a mid-frequency array in Southern Africa, and a low-frequency array in Western Australia. Now, as well as being designed to answer some of the key questions in modern astrophysics, the SKA is, by any measure you choose, a big data machine as well. And this means that many of the governments that are involved in the construction of the telescope are interested in it not purely as a scientific endeavor, but also as a tool of economic development, because the data volumes that we're talking about for the SKA really put it at the forefront of big data technologies. The telescopes individually will produce about 300 petabytes of data each per year, and that's the size of the compressed data products. If we were to store all of the raw data within the SKA low telescope, that would be about 5 zettabytes of data per year. Of course, that's ridiculous, so we'll just satisfy ourselves with, a mere 600 petabytes per year. But even so, that's really right at the forefront of not only data transport and storage, but also modern signal processing in real time, because a lot of the processing has to be done in soft real time, and also requires something of a step change in the way that we analyze those data within astronomy in order to extract scientific value in a reasonable time frame. And so the SKA itself represents a big data challenge that can be used to innovation and to leverage the importance of new technologies in that computing, big data, AI space, all of which are, of course, highly relevant for what's now being termed the fourth industrial revolution, that is, economies that are data driven. And of course, these things were in the minds of the signatories to the treaty that established the SKA as an international governmental organization in 2019. You can see the signatories there on the right, the headquarters of the SKA in the upper figure, and the Meerkat telescope, which forms the first part of the mid-frequency array in Southern Africa for the SKA in the lower figure. But moreover, as Simon Berry put it, the SKA was also one of the first international scientific infrastructures which also had education and outreach embedded in its development from the earliest stages. And this was important for many reasons. And in particular, across Africa, it was quite important because South Africa was a major partner in the SKA. The Meerkat telescope is a great testament to the South African skill in radio astronomy. But South Africa itself was supported by a partnership of 8 other African countries, forming the SKA Africa Partnership. Now, like South Africa, like the UK, like pretty much all of the partners in the SKA, those countries in the SKA Africa Partnership saw the SKA as a tool of economic and technical development. However, for many of those countries, there weren't existing astronomy research bases, certainly not radio astronomy research bases. And so there were a number of initiatives that were created to support the development of radio astronomy communities within the SKA Africa partner countries. And a major one amongst these has been the DARA project. So this is the Development in Africa with Radio Astronomy project. So the DARA project with the support of partner universities in all of the SKA Africa partner countries, developed a training program for honours year students in radio astronomy. And you can see part of the cohort here. And this was to start a pipeline of training and skills development around radio astronomy, technical radio astronomy, computing, and data analytics, so that those countries could establish a research base and could participate meaningfully in the science of the SKA, as well as to partake in that associated economic development. And the DARA project has been incredibly successful. Hundreds of students have been through the DARA basic training program, and the advanced program has provided support for PhD and MSc bursaries for higher level qualifications around radio astronomy. Now, from the DARA project, the DARA Big Data project was born, a sister project that really exploited the data science and computing aspects of the SKA project. So I'm not going to tell you about DARA Big Data myself. What I'm going to do is I'm going to let our students tell you about the project.
The DARA Big Data project provides training in data-intensive science skills to students from the countries of the SK Africa Partnership, which are Botswana,
Ghana,
Kenya,
Madagascar,
Mauritius,
Mozambique,
Namibia,
and Zambia.
Data-intensive skills are crucial for countries to play a role in the fourth industrial revolution, the global shift towards digital technologies and artificial intelligence.
These skills are also crucial for the SK telescope, the world's largest radio observatory, which will be built on the African continent.
DARA Big Data training events happen across Africa. The project also provides financial support for students to study postgraduate research degrees in data-intensive fields. This includes astronomy, sustainable agriculture, health data, and science policy.
We are not all astronomers, but astronomy has brought us together.
DARA Big Data and the DARA project have supported the growth of a strong Pan-African community of students.
Together, we have studied, communicated, traveled, and taken part in events.
This community grows and develops each year and gives us support, friendship,
and a network of professional contacts across Africa.
And as you can see at the end of that video, the DARA Big Data project, along with the DARA project, is a partnership between the UK and South Africa, and it's jointly funded through the UK and South African governments through the Newton Fund in the UK and the Department of Science and Innovation via the NRF and the South African Radio Astronomy Observatory in South Africa, which has been a very fruitful partnership for the projects. Now, one of the reasons why DARA Big Data is a broader project than the DARA project itself is because it wanted to address not only the computational challenge and opportunities for the SKA, but also the translation of the skills from the SKA into other data-intensive areas, scientific or industrial. And astronomy is a particularly good area of science for doing this. Astronomy is what's often referred to as a gateway science. It's a branch of science that is very attractive to young people, and so it draws them into scientific careers where other fields of science may not have done so. And of course, like most other branches of scientific research these days, astronomy is heavily data-driven. And so data science, what we now refer to as data science, which also incorporates artificial intelligence and machine learning, as well as the large-scale computing that's required for that kind of data analysis, that data science and that big data computing are both horizontals that sit through astronomy. And so what that means is that we can use radio astronomy and astrophysics as an enabler to develop those skills in a larger cohort and translate them into other areas. And so when we were developing the DARA Big Data project, one of the key questions we asked ourselves what were the key areas that we should be targeting for this development. Now, of course, there are specific development questions that are more relevant in some parts of the world than others. Our own students have very strong opinions about this. So here's a quote from one of our DARA Big Data alumni. So Dr. Lamek Amagongo, who did his PhD at the Christie at the University of Manchester and is now a lecturer at the Namibia University of Science and Technology, saying that he believes that health questions are the biggest questions that should be addressed on the continent. Of course, Lamek himself works in cancer research, and then other questions such as those of agriculture and sustainable food chains are also very pressing questions, not only in Africa, but in many other parts of the world. And so these were the areas that we decided to combine with astronomy in the DARA Big Data project, not only because of their relevance for Africa, but also because of the historical and technical connections between the three areas, especially around the use of spectral data, imaging data, and the way that the measurements are taken, in fact. So the way that the measurements are taken in both many areas of health, particularly cancer research and agriculture, using Earth observation, have significant similarities to astronomy. And the strength that we really saw here was that if you target health or agriculture individually, then you immediately address two of those, the Sustainable Development Goals that the UN transcribed so effectively. But if you put together these three areas, along with that data intensive aspect, you actually manage to target a much larger number of Sustainable Development Goals. And so this project was really designed to have an impact that was greater than the sum of its parts, to target a much wider range of development objectives. Now that I've given you a bit of background on the project and the SKA, I'd like to talk a bit more about the practicalities and the logistics of the project itself. The video that you saw earlier was made for a forum preparing for the General Assembly of the International Astronomical Union, which will be held in Cape Town in 2024. And the students that you heard from in that video are postgraduate students who have their PhD and MScs supported by the DARA Big Data project. But as well as those students, DARA Big Data also runs a series of workshops in all of the SKA Africa partner countries, as well as a flagship summer school, the Big Data Africa Summer School, which is run by our partners, Soreo in South Africa, with our support. And you can see here a picture from the third Big Data Africa School, which was held in 2019 in Cape Town, in case that isn't obvious. And on the left-hand side, you can see some pictures from the project groups. In fact, actually, so at the bottom left, that's a project group at Big Data Africa. And at the top left, that is a project group at one of our workshops in Antananarivo in Madagascar. Now, these workshops and the summer school are designed to create a pipeline of skills development, going from an undergraduate to a postgraduate level, and giving students a taste of the kind of things that they could work on in data intensive fields, particularly sustainable agriculture, health data, and astronomy. So all of our workshops and our hackathons and our summer schools are project based. So we do this in partnership with a number of organizations, including the Office of Astronomy for Development, where we support a fellowship for a fellow to develop hackathons that look at data-intensive problems where skills from astronomy can be applied outside astronomy. And of course, these data-intensive problems also need computing support. So the Centre for High Performance Computing in South Africa and the Institute for Data Intensive Astronomy, which runs the Alifu Cloud, have also been integral partners to the Big Data Africa Summer School and to the Dara Big Data project more widely. Of course, like everyone else, during the pandemic, we had to pause our in-person workshops and summer schools. We did continue with online hackathons. We supported a number of online events, and we also supported the Africa Data Science Intensive Programme, which is another programme that is run by our partners Soreo in association with AIMS, the African Institute for Mathematical Sciences, which runs in a very similar way to Big Data Africa. It's a project-based summer school, essentially. And one of the considerations when you're making a project-based summer school is the number of students that you can support. We work with small project groups, all of whom have individual mentors and technical leadership. And so the numbers are necessarily very limited. So for Big Data Africa, we limit our numbers to 25 students. And for the Africa Data Science Intensive Programme during the pandemic, there was a limit of 16 places. And I just wanted to highlight this as an example of the appetite that there are for these programs. For the Africa Data Science Intensive Programme in 2020, there were 1,430 applicants for 16 places on this programme, which is a huge number of applications. And so I would say one of the things that I would like to highlight here is that there is immense scope for developing more of these programs associated to other big science and data intensive problems, because students certainly want to participate. The other thing that's been particularly edifying in our most recent Big Data Africa summer school, which happened earlier this year, so slight gap from 2019 to 2023, so that's Big Data Africa 4, we actually had more than 50% of the applications came from women. And female participation in our programs is something that we have been tracking. And again, our partner Soreo actually produced a report in March 2021 on women in data science using the numbers from the Dara Big Data programs, not only to examine the participation of women in our data science events, but also to look at the factors that affected their participation. So if this is something that you're particularly interested in, I do recommend this report. It concludes with a set of recommendations for increasing female participation in these kinds of events. And we've been very pleased with our progress in this area. I should also say that we also held an International Women's Day event online to mark the publication of this report in 2021. And we had roughly 1,000 women from across Africa sign up for that event. So where are we now? Well, so this is a photo from Big Data Africa 4, which happened earlier this year, again in Cape Town. You can see our participants and our tutors here. One thing that's been particularly nice is that the program's been running for a sufficient amount of time that many of the students who have done their MSc and PhD through the Dara Big Data program have gone on to become tutors at our workshops and at the Big Data Africa Summer School. We've also been expanding our partnerships. And so earlier this year, we did hackathons, both Hack for Dev hackathons with the African Astronomical Society and with the University of KwaZulu-Natal. And on the top left there, you can see our Dara Big Data fellow, Nikita Madampal, holding the globe in the front. So Nikita is based at the Office of Astronomy for Development at the International Astronomical Union in Cape Town, and she has just finished her fellowship developing hackathons for the program. I think one thing that's quite important to understand about running these kinds of hackathons and events is that it's not simply about developing the hack itself. So whilst that is something that's important to us, all of our hacks are publicly available, the data are available so people can reuse them as they want, but also we provide local support, and that has been extremely important, especially when we're holding the first hackathon in a new location. So some of the things that underpin our hackathons are, of course, access to computing resource. Now, for many of the partner universities, they don't have a substantial amount of computing resource locally. And if they do, it's not necessarily appropriate for doing data-intensive data analysis. And so this is where the Center for High Performance Computing and the Alifu Cloud have been very important for the Dara Big Data project. So being able to host our projects on the Alifu Cloud so that they have their own cloud instance has been absolutely wonderful, because then all of the participants can log into a consistent environment. We don't have to deal with local software environments. We don't have to deal with heterogeneous platforms. And so HPC in general, and I use the term HPC in a much more generic sense. So I think that HPC is a term that has evolved over time, whereas historically it has been used to mean, monolithic thousands of CPU core machines. I think HPC now is a more general term for high performance computing, because certainly the problems that we deal with are heterogeneous problems, and they require heterogeneous compute resources, whether that's HPC, HTC, cloud, or for AI, large scale GPU clusters. So we need to be able to be flexible in the computing resource that gets provided for a specific problem. So having the computing resources of the Alifu Cloud and the CHPC behind the project has been very, very valuable. The other thing that is very important for our projects is network capacity. And I cannot emphasize how important this is for research communities across Africa, is being able to access non-local compute resources in a consistent manner. So this is not possible everywhere, and the degree of access varies significantly. And so it's something that I really hope is going to be a priority for organizations such as the African Open Science Platform, as they look at their priorities for the next few years. But for the moment, we're certainly getting by. So to conclude, I'd just like to say thank you again to the organizations that support the Dara and Dara Big Data project, the UK Newton Fund and the DSI in South Africa. I should say that the current funding for the project has now finished. So our future is rather uncertain at the moment, but of course we're optimistic. And if you'd like to know more about the project, if you'd like to use our resources, or if you'd like to hear more from our students, please visit our websites. There's a website for the Dara project, for the Dara Big Data project, and one there for the data science intensive program run by Soreo and Ames. And of course, you can follow us on social media. And if you have any questions, I should be online to answer them.
Thank you much, Anna, for the fascinating talk, and thank you for bringing the human capacity development aspect of high performance computing into the picture.